understands the pattern, correlates events, and gives actionable insights. Whereas a traditional tools generate alerts only, whereas an AIOps generates decisions. Let's take a use case. Large enterprises with thousands plus devices gets multiple alerts triggered for just one single issue. Without AIOps, the engineer has to manually intervene it and check all the alerts. With our AIOps service, the system correlates it, shows a single root cause. What is the outcome here? The troubleshooting becomes very faster, less dependency on the manual effort. Okay. What is the role of AIOps? Okay, in the current trend of the market? It helps in forecasting resource utilization and prevents bottlenecks. The potential failures of all the devices are identified before even the impact is on the user, creates multiple alerts to a single root cause. The thresholds are automatically adjusted based upon the number of inputs, detects abnormal behavior beyond the predefined thresholds, filters alert thresholds to highlight only actionable insights. So from this, we can conclude that from a reactive monitoring, the system is turning to be an intelligent and predictive operations. Okay. So now let me introduce what is Infraon AIOps. What are the core capabilities of the Infraon AIOps? So we have predictive analysis, forecasting, the anomaly detection events, seasonal event interface, event association mining, and predicted events. Okay. There are certain prerequisites for the current system what we have. For a predictive monitoring and predictive analysis, we need minimum 15 days of history of old data of the NMS data to 30 days. The futuristic generated data will be for 15 days, and this will be applicable only to the adaptive thresholds. Here, the algorithm used is machine learning, and this model will be triggered on every Sunday. Whereas when you see for the same for a forecasting, or capacity planning, we need minimum 15 days to 90 days of polled data to have futuristic generated data for 180 days. Here, the application is forecasting trend, and we use a stat-based model here. And again, this model will be triggered on every Sundays. Okay, and in case if you want to trigger it immediately as and when the time is required for the customer, this can be configured. Okay, so before we get into this, why do we need AIOps? The key problem here in today is not lack of tools. It is too much of data. Teams are overwhelmed with alerts but lack clarity. AIOps solves this by turning data into meaningful insights and faster decisions. Huge manual operations cannot scale with modern IT environments. For example, in a banking or e-commerce outage, 10 minutes downtime is equal to huge revenue loss. Alerts flood in the knock windows or knock teams or knock displays. And there is a huge delay in identifying where is actually the root cause. What is the failure? Where is the failure? Huge flooded of alerts will have caused huge confusions. Manual intervention again to find the root cause itself will take a huge lot of time. Okay, this is without AIOps. With AIOps, there is an instant correlation happening here. The root cause analysis is much faster than the human effort. The reduced downtime impact. Okay. In today's network, there are huge number of hybrid environments, on-prem plus cloud, increased device complexity, high dependency on network uptime, user experiences directly impacts the businesses. Okay. As when we conclude here, networks are no longer infrastructure. They are business enablers. Okay, there have not a few, there are quite a large amount of challenges faced by the IT teams. Thousands of alerts just gets randomly triggered every day. Lack of visibility across the environment. Manual troubleshooting. They should find where is the actual issue. Okay. So reactive approach, issue plus fix it is again to be a repeated task on everyday basis. Okay. The traditional monitoring fails short. As you see, there is no correlation between the events. There is a soiled monitoring tools, static thresholds, which gives huge amount of false data. All these have been avoided in the AIOps service engine, which has been inherited into the existing systems. Okay. So now let's move on to the key features of the service which we provide from the AIOps of Infraon. So you can see in the adaptive thresholds, automatically it adjusts the thresholds. It predicts the future events, learns from the past behavior, adjusts in real time, detects anomalies. Here in a detailed content, we will be seeing how is the adaptive threshold working. This replaces the static thresholds with dynamic baselines. This learns on the daily pattern, weekly trends, seasonal variations. The thresholds gets adjusted based upon the patterns. Okay, let's take a case study here. So when the CPU usage spikes every day at 10 a.m. due to a batch jobs, the static threshold reaches up to 80%, frequent alert rises. Okay. With AIOps, this pattern is being learned that it knows this pattern is consecutively occurring and no alert during this expected spikes. Alerts only where there is a deviation occurs. Somewhat between 10 a.m. to 9 a.m. is what is expected, but something happens above the predicted time or the varied time, then the spikes, the events occurs. What is the outcome of this? Not every spike is a problem. AIOps understands what's normal for your environment. Okay, this is all about the adaptive thresholds. This is one of our tool level. Okay. Predictive and anomaly events. Okay, so when we talk about predictive and anomaly events, this identifies the deviations from a normal behavior. Anomaly usually works even when thresholds are not breached. This detects sudden traffic spikes, latency variation, unusual device behavior. Let's take a case study here. The network traffic increases slightly but stays within the threshold. Without AIOps, there is no alert detected. But with the AIOps, you can see the detects usual unusual patterns, flags anomaly here on particular point of time. Okay. So thresholds can miss problems, but anomalies can never lie. Okay. Again, there is another feature which we call it as a predicted events. Okay. Here, this uses a time series data plus the machine learning models, which detects the patterns leading to failures, the device failures, interfaces, saturation, performance gets degraded, moves monitoring from reactive to predictive approach. Okay. Also, it helps in providing forecasting into potential different disruptions before even they impact the users. This reduces the mean time resolutions by shifting to proactive response. Okay. So when we take a use case, when we talk about a use case, a core switch shows increasing temperature and CPU spikes. Without an AIOps, no alert is reached until a threshold is breached. Sudden device crash. But with our AIOps, this gets detected abnormal trend deviation, plus it predicts the potential failure in the next 48 hours. Okay. AIOps does not just tell you something is wrong. It tells you something will go wrong according to the predictive events. This is all about the predictive events. Okay. Next is forecasting, proactive capacity planning, which uses the historical performance data. It helps in the applies trend analysis either in the linear regression or in the machine learning models. Forecasts future utilization patterns. It identifies which resources it gets exhausted on timelines. Okay. So let's take an example here. Okay. So a company has multiple branch offices connected via MPLS. WAN utilization steadily increases due to the traffic which is getting spiked from the utilization which has been caused on that particular point of time. So by without having an AIOps, there is no visibility of why exactly the utilization hit 95%. Only it gets only notified only when a user's complaint about the slowness. But with using our AIOps, Infraon AIOps service engine, this link will reach 90% utilization in the next 20 days. The system is predicting all these kinds of events in earlier than before it is affected. the IT tends to upgrade the bandwidth before even it is getting impacted. You can also take another example here. Okay.
Yeah, so Dinesh, one query. So it
Yeah.
will basically analyze your data,
Mhm.
right, day to
Mhm.
day, right?
Yes.
So how
Yeah.
much data or the memory or the
Exactly.
CPU utilization is utilized by the server, right? On the basis
Exactly.
of that, it will predict your future analysis of the how much it will consumed, right?
Yes. 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 Yes.
Okay.
Exactly. This can be applicable not only to your network devices, it can be applicable to your servers also. Say for
Mhm.
another example, when you take a disk in a server, instead of getting a threshold which says that your disk is 90% full or 100% full, the system will tend to see the pattern of consumption on a day-to-day basis. It will basically tell you that your disk is going to be full on next 2 days. Either
Mhm.
you add resource or you can clean up your pre-existing resources to that particular server so that
So
the dex means the digital employee score is not affected.
so to forecast this, we
Okay.
need to set the threshold first. After that, it will start the prediction, or by default, it will have some
By by default we have
base
multiple thresholds which is
baseline.
set.
Okay.
If you want to alter the thresholds, you can alter the thresholds.
Mhm.
It is configurable. It depends on
So
the.
by default, we have the baseline setup.
Yes, yes, yes. Instead of reacting, we get time to act upon how it is going to be affecting in our resource or the productions. So we get time before it is even causing a revenue or the production loss. So in that way, you can take a report also in a downloadable way, or you can mail it. And we have multiple features on how this works in our infra. This works. This kind of feature works with the system and the
So
service
this
engine.
so this tool monitors and manage your network servers from a single console,
Exactly.
or we have the different console.
No, this tool monitors. This is all about the Infraon IMS. It is also applicable to the NMS plus infrastructure monitoring means this kind of feature can be added to your router, firewall switches, your any device which has statistical information. We can put this in simple, in general words.
Mhm. Okay. Okay. Thank you.
Okay. So now comes up with the seasonal event separations. Okay. Here, the seasonal event separation identifies recurring patterns in alerts and events over the time. It learns in a daily, weekly, or monthly behavior trends. For example, in every day, when people come, let's take a banking as an example in this case. So for as a part of seasonal event, morning 9 a.m., the people come in and till 5 a.m. they work and then just go. Every day there is a spike at morning 9 a.m. since everyone is into the office, and after 5 p.m. everyone is out the office, then the utilization comes down. Okay. Suddenly when there is an event which is occurred at 7 a.m. or 7 p.m. or 7, 8 a.m., 9 a.m., 1 p.m. This someone. So this is occurred as a this kind of pattern is called as a seasonal event pattern. Okay, so the system knows that morning 9 a.m. people come, then the events traffic gets spiked, and they know that after 5 p.m. it comes on. So it does not identify it as an anomaly. It knows that what is to be done at that particular point of utilization. Okay, it basically analyzes your historical event data, detects the time-based patterns, like classifies it. Is it peak hours? Is it batch jobs? Or whenever you use for your NCCM, when we look into a batch jobs, a huge number of configurations are posted on particular point of time, on a regular interval of time. So it identifies this as a seasonal event which is occurring at that particular way by having the future historical data again with it, and then it will not cause any unwanted or anomaly detections in that particular point. Okay. The here in most of the common environments, not all alerts are problems. Many are repetitive and expected. Okay. For example, as I mentioned, in every day at 10 a.m., you might see that the CPU spikes due to scheduled jobs. In another example, traditional monitoring treats this as an issue every time. But AIOps learns this pattern and understand that this is a normal behavior. There is the difference. So instead of alerting repeatedly, this gets suppressed, these seasonal events, and only alerts when something deviates from this pattern, as I mentioned previously. Okay. So this significantly reduces noise and helps to focus only on the real problems rather than having multiple false alerts only on the real problems. This is where the use case of let's take another use case in the daily batch processing when a huge number of configurations are pushed. The CPU spikes. Alerts get triggered without an AIOps. Knock ignores the alerts as a fatigue. With seasonal separation, the system learns the pattern. No alert is being expected here. Alerts only if it exceeds the normal behavior, as I said in a banking structure. Okay. Even you can take another use case of an e-commerce traffic spikes. So whenever there is an sale which is being given on the e-commerce like Amazon, other e-commerce websites, right? High traffic during weekends or sale events. So the AIOps will learn the seasonal traffic pattern with the help of the historical data and avoids false alarm during the expected spikes. Okay. So the next feature what we have is associated events summary widget. Okay. So in this, if you can see here, usually many events are grouped using topology awareness, dependency mapping, pattern recognizing. This helps identifies the root cause versus the symptoms. They accelerate multiple analysis by grouping multiple dependent events on multiple interferences. Okay, and helps in correlating events contextually. So let's take again a use case here. So when we talk about uh, a core switch which fails suddenly or due to any disaster, what kind of general alerts do we get? The server is unreachable, application is down, interface is down, latency spikes, 100 plus alerts gets triggered, manual investigation is required without an AIOps, which the system has been identified. But with our service engine, you can see that all the alerts are being correlated. The root cause is finally found not after the investigation is done. It is found before itself of the investigation is even started. This will directly tell you what is the root cause, where is the actual parent failure, rather than investigating on the child's. Okay. So as an outcome, you can see your MTTR is reduced drastically. Okay. So there are multiple key takeaways for Infraon AIOps service. So you can see the operational, there's a huge operational scalability, contextual alarms, a heavy load on the incident response is reduced, the infrastructure uptime is drastically improved. There is a reduced investigation as you don't have to spend times on investigation, everything is done automatically. Okay. So let's take another final example in real world, combining all the AIOps features to a real world use case. So from all the alert chores to an intelligent clarity, which gives for the all engineers or the technicians who are working on this particular software. Okay, let's see a core device network is about to fail. Let's take a core device, basically a core network device is about to fail, but the system does not wait for the failure. Without an AOps, this will be triggered only when there is a failure. But let's assume that we have all the features in the system. So the system will not wait for the failure. First, taking into the first feature, predictive monitoring identifies the early warning signs. Then the anomaly detection catches the unusual behavior even before the thresholds are crossed. Whereas the adaptive thresholds ensure we do not get unnecessary alerts for the expected patterns. Now is a time where you can see that when the issue actually impacts the network, AIOps correlates all the related alerts and shows a single root cause. At the same time, we can also see that huge amount of noise suppressions is being ensured for the NOC team as they see only what is required for them to see. Unwanted of all fake alarms or the false alarms which is getting flooded in their NOC windows. And finally, we can see there is a proactive capacity planning which is being created to ensure that we avoid similar issues in the future. This is how an AIOps transfers or transforms the operations from a reactive troubleshooting to intelligent decision making. You can see there is a reduced downtime, smarter operations, and faster resolutions. So we have multiple cases or multiple use cases where we have seen our AIOps features have been very flexibly and utilized and helped our customers to ensure that all these things and all our features or use cases what we have said is being achieved for a multiple and different customers. So as far as AIOps is concerned. So to have any future or even more in-depth demonstration, you can always reach us to us. Our Infraon AIOps service is always there to help our customers to achieve all the features and the scope what has been defined in it. Thank you for giving us and giving me this opportunity to. Thanks.
Yeah.
Thanks, Bharati.
Thank you so much, Dinesh, for this insightful session. I really hope everybody had a really insightful session on AIOps. So we truly appreciate you all for your time and your patience to be listening to our webinar. And I just want to tell you, I have dropped my details in the chat box. You can please reach out to me anytime if you want a demo on it, or if you want to know more about our company and our different products that we have. So you can reach out to me at bharti.anand@infront.io or the number that I have shared. And to close this with, like Dinesh mentioned, AIOps is not just about managing IT better. It is about making IT smarter, faster, and more proactive. So I wish to see you, you know, you all, talk to you all and discuss more about how we can work together, right? So if you have anything, maybe you can drop us here, and we would be really happy to address about it.
Yeah, is anyone having any queries? Maybe we can react on it. Anyone has any queries?
So can we get the binary to evaluate the tool or?
Yeah, you can get so. You can reach out to Bharati after the
Mhm.
session. You can have the time or the phase of evaluation can be done always. Welcome.
Okay, sure. And
Sure.
also, can we get the competitive analysis against SolarWinds or Manage Engine?
Yeah,
How? Yeah.
we can do that. So we can do that.
Okay.
Clearly,
Yes.
post this webinar, I'll be reaching out to you, and then we'll have a discussion on it, and I'll also share you that whatever you have asked for.
Okay. Sure, Bharti.
Okay.
Sure. Thank
So
you.
anything else from any? Thank you so much, Nitish. Anything else from anybody, or can we wind up the session? Great to know. I don't think anybody else has doubts. So thanks again.
Yeah.
Thank you all for
Thanks,
joining the
everyone. Yeah.
session. We'll wind up this now. Thank
Yeah.
you. Have
Thanks,
a
Thank you.
great
Bharati.
Thank
evening.
you.
Thank
Thank you,
you.
everyone.
Thank
Bye bye.
you.
Thanks.
Thank you.
Bye.
Thank you.
Thank you.